In today's discussion, we are going to talk about binomial expansion. So I have different questions under the same topic, and we're going to explore different type of questions under binomial expansion. So as you can see, I have got this tutorial sheet that we are going to solve. So we have got a lot of questions from question 1 all the way to the last question, that is question 13. Okay, so we are going to solve these questions one by one. So what I'm going to advise you is just get a paper or a book and a pen. Try to pause the video, try to work it out, and then compare with the answer that I'm going to be finding. Okay, so let's begin. So the question is find the value of the following. We have 7, choose 3, that is part A. Part B, 21, choose 22. And part C, which is saying 9, choose 3 plus 9, choose 4. So initially, when you have got a question which is in a form of this is basically the same as if you have got a question in a form of n, choose r. The formula which you are supposed to use is factorial. N factorial divided by n minus r in the brackets factorial times r factorial. So in this case, when I'm talking about factorial, let's say I've got 2 factorial. So 2 factorial is basically 2 times 1. So if I give you 4 factorial, so 4 factorial is 4 times 3 times 2 times 1. Okay, so if I give you 5 factorial, this is the same as 5 times 5 times 4 times 3 times 2 times 1. So initially here what we have is 7, choose 3. Meaning, just following this formula, I can clearly see that it will be 7 factorial divided by 7 minus 3 in the brackets, then factorial times 3 factorial. Of which I know that is going to be 7 factorial divided by 7 minus 3 is basically 4. So I've got 4 factorial and 3 factorial. Okay. Now from here, what I'm going to do is down here I've got the biggest number I have is 4 factorial. So I'm going to express this 7 in a such a way that I should leave where there's going to be what 4 factorial. What I mean is this. If guys have got 4 factorial, we are saying this is the same as 4 times 3, okay, then times 2 times 1, of which I can also, if I want, I can end on I can say 4 factorial is, we can see the trend here. We are starting from 4, 3, 2, 1. So as you are going, you are reducing it by 1. So it's more like we're doing minus 1. So I can say it is 4 times 3 factorial, because 3 factorial is 3 times 2 times 1. If I want to go further, I can say this is the same as 4 times 3 times 2 factorial. I end there. So this is the factorial theorem which I'm going to be using here. Okay. So for 7, I'll say it is 7 times 6 times, what else do I have? Times 5. Then when I reach at 4, I'm going to put 4 factorial, because I've got 4 factorial down there. Again here I'll have 4 factorial. But 3, I'll simplify. I'll say 3 times 2 times 1. So 4 factorial and 4 factorial can go. Then we'll say 3 there, 3 there, 2. Then 2 and 2 will cancel. So I've got 7 times 5, which is 35. So in this case, my answer is 35. So I would request you guys to help me to solve part B. Then send me the answer. I have to check the answer for B, but I'll go ahead and solve C using the same method. Okay. So I'll go to C. You solve B using the same method. So B, we need to do it separately. Okay. I'll do this part alone and also that part alone. Then later on I'll come and add them. So 9, I'll first deal with 9. So it will be 9 factorial divided by 9 minus 3 factorial times 3 factorial. Okay, I'm just following the formula which I gave you. So this is 9 factorial divided by 9 minus 3 is 6 factorial, 3 factorial. So it will be 9 times 8 times 7. When I reach at 6, I'll put factorial, because down here the highest number I have is 6 factorial. So I'll put 6 factorial. 3 is going to be 3 times 2 times 1. The same as just 3 times 2 anyway. So 6 factorial and 6 factorial will go. And then I'll say 3 there, 1. 3 here, 3. Then 2 there, 1. 2 there, 4. So what I've remained with is 3 times 4 times 7. What is the answer? 3 times 4 is 12. Okay. 12 times 7. So what is 12 times 7? It's 84. So the first part I have found 84. I need to add the 9 choose 4. Allow me to get rid of this. I create space. Now I want to find 9 choose 4. So 9 choose 4 will be equal to 9 factorial divided by 9 minus 4 factorial, then 4 factorial. So we have 9 factorial on top. Here we have 5 factorial, then 4 factorial. So 9 times 8 times 7 times 6, then times 5. Once I reach at 5, I'll put factorial. That's the highest number I have on the denominator. Then 5 factorial. 4, it is 4 times 3 times 2 times 1. Let us see. 5 factorial will go. So 4 there, 1. 4 here, 2. Of which these 2 and that 2 will also go. And remain with the 3 on the denominator. 3 there, 1. 3 there, 3. So I have now 3 times 2 times 7 and times 6. So what is the answer? So 3 times 2, 6. 6 times 6, 36. 36 times 7. Okay. So we do 36 times 7. So 36 times 7. Oh wait, so that should be 256 or 252, because these two I'm going to get 42, so it will be 2 carry 2, 21, 21 plus 2, yes, oh, carry 3 anyway, so it's going to be 256, not so 252, not 256. Yeah, so now after finding this, the only thing I need to do is just to add. So I have, I'll do it from here. I have 84 plus 252. So my final answer for that question is 336, because that will be 6, 13, 1, 332, 336. That's the answer. So that is it for question 3. So I'll be waiting for the answer for question B. So for those who doesn't have my number, if you want to submit the answer for part B, you can get in touch with me using this number. Can get in touch with me using this number. So submit the answer for, or if you'll be able to put the answer in the comment section is fine. I'll still be able to check it out. Okay. So let us look at this question, which is saying for any positive integer n, show that part 1, which is part A, n choose 2 is equal to n squared minus n over 2. So we are just proving. So the basic idea that we have to understand here is we should know that whenever we have been given n choose r, this can be expressed as n factorial divided by n minus r in the brackets factorial times r factorial. Okay, so now when I use this formula, I'm going to start now manipulating this thing that I have here until it comes out as that. Okay, so using the same concept, let us go ahead and do that. So n, choose 2. Using the formula, it is basically n factorial divided by n minus 2 in the brackets factorial divided by 2 factorial. So now I want us to understand one thing about factorial theorem. So under factorial theorem, if I have been given 4 factorial, this is basically the same as 4 times 3 times 2 times 1. Okay, so then if you look at this, we can clearly see that this is 4. So the next one that I have, it is basically 4 minus 1, that is what? 4 minus 1, that becomes 3. The next one is 4 minus 2, that becomes 2. Once I decide to end there, I put factorial. Then that is okay. So this is the same principle that we're going to be using. Now remember, I don't want n minus 2 in the brackets factorial to appear on the denominator. So I need to find a way on how I'm going to manipulate the top part so that the n minus 2 factorial down should be eliminated. So if I have got n, remember, factorial, you write the same n. So the next one is going to be n minus 1. This is the same principle that I've been giving you, that I was giving you here. So if I decide to end there, I'll put factorial. But in this case, I'm not going to end there because I want n minus 2 to appear. Next, I'll say n minus 2. Because I want to eliminate n minus 2 down, I'll end there and put factorial. So where there is n factorial, I'm going to replace it with this. So that goes like this. n minus 1, n minus 2 factorial. I divide it by n minus 2 factorial. 2 factorial is basically 2. Now the n minus 2 factorial can cancel. Now I have got n minus 1 on top divided by 2. Now if I expand the top part, n times n is n squared, n times 1 is n divided by 2. I can clearly see that what I have this side is basically the same as the one I have here. Okay, then I'll say left hand side is equal to the right hand side, hence shown. As simple as that. Now, using the same concept, guys, try to pause the video, solve part B, and compare with the answer that I'm going to find. So there we go. We have this part that is going to be n, choose 3, that becomes n factorial divided by n minus 3 factorial times 3 factorial. So again, my goal is to eliminate n minus 3. I'll use the same principle. So n factorial, so this is what we call factorial theorem. So n factorial is basically, I'll start with n like we did, n minus 1, n minus 2, then n minus 3. As long as I decide to end there, I'll put factorial. So I'll go there where there's n, I'll put n minus 1, n minus 2, n minus 3. I'll end there and put factorial. The down part, it is also n minus 3 factorial 6. 3 factorial is 3 times 2 times 1, that is 6. Now the n minus 3 and n minus 3 factorial will cancel out. I'm now remaining with n minus 1, n minus 2. I divide that by 6. Definitely this is exactly as what they want me to show. So therefore left hand side is equal to the right hand side, hence shown. So that's the basic idea behind this type of questions. Okay,
So we're proving nr being added to n choose r minus 1 is equal to n plus 1 choose r. This is a very interesting question, so pay particular attention. Let's move step by step. So if you've dealt with a binomial coefficients already, feel free to just pause this and just try it out. So I'll not use my notes, I'll try to be real so that you basically understand how you'd go about it if you find it in an exam on your own. Okay, so for the first part, we already know what that means. So that means n factorial over the difference, which is like n minus r factorial, and then of course r factorial plus n factorial over r minus 1 factorial. Now think about this. If you look at it, let's assume we want to basically get to add the two. Okay, I already explained the basic ideas about the coefficients of the factorial already, so that you basically get the concept. Now there's something that I've already forgotten of. There's a mistake I've made here. Okay, so it is the n on top minus what is on the bottom. On the bottom we have r minus 1, right? So minus r minus 1, and then of course factorial, and then r minus 1 factorial as well, just like we've done on the first part. N factorial on top, on the bottom the difference, and then also r factorial itself. Okay, thank you for that observation. So now I can simplify it to the next step. N factorial, so n factorial of n minus r factorial plus n factorial. Now if we do subtract what's in the bracket there, r will become negative, 1 will become positive. So you have n minus r plus a 1 factorial r minus 1 factorial. Now the beauty about this is, I'm sure at this point you've already observed something common, right? You've observed something common about what we have. If you check the first two brackets, they are deleted in a certain way. The one on the right is just one higher than the other. And then again, if you compare r and r minus 1, one is just higher, right, by 1. So r itself is higher. R minus 1 is less by a 1. So we can somehow expand the bigger ones so that they can showcase the other one. What I mean by that is, we'll apply this. We know that let me start with r. R is bigger than r minus 1. Okay, so I can expand the bigger one, which is r. So r factorial, let me use a different color there. So r factorial is basically equal to, I can expand it by reducing it by 1, r minus 1 factorial. And then this one is bigger by a 1. I can also say n minus r plus 1 factorial is also equal to n minus r itself plus a 1. If I reduce it by a 1, it will give us what? It will give us, the 1 is going to disappear, so it will be n minus r factorial. So you understand why I've done all that. So I'll leave the top part. So I'll expand. So we have n factorial over, now why is r factorial, we'll put that. So we'll maintain n minus r. Now we said r factorial is bigger, so it is, we can expand it as r minus 1 factorial plus the other side, n factorial is to be maintained on top. Now this part has been expanded. Okay, so it's equal to n minus r plus 1, and then if you reduce it by 1, it gives you just n minus r factorial. And then don't forget you have r minus 1 appearing as well. So I've just substituted on the part where I've got r and the part where we have n minus r plus 1. We've expanded them by reducing by 1, just like we said. If you have 7 factorial, it is the same as 7 times 7 minus 1 factorial, which is of course 6 factorial. Okay, so we're just using the binomial coefficients principles. I meant to say factorial notations. At this point, we can factorize something, that is things that we can notice that they're common. I can see on top we have n factorial is common. On the bottom, what do you think is common? I can see this part is common. That's the reason why we're expanding, to come up with some common terms. And then I can see r minus 1 factorial is also common. So we'll start with n minus r factorial, and then we have r minus 1 factorial. Those are the two things that are common on the bottom. Then on top, of course, we've already factorized n factorial, so we have a 1 for the first part. So for the first part, if you are to remove these from the bottom, what only remains is r plus. For the other part, if you remove the other two, only this part, only that guy will remain. So it's 1 n minus r plus 1. Okay, so we've just like dealt with that guy. So at this point, we can try to simplify what is in the brackets. Okay, so of course we understand we need to come up with a common denominator and all that. So what's a common denominator if we were to look at the two there? So we have r multiplied by n minus r plus 1. Okay, so what's standing out on top? So r into this, we just get n minus r plus 1, and then if you divide that, you get r, so plus r. So you're noticing that on top the r will cancel out, so that you remain with n plus 1 over r, and then multiply by n minus r plus 1. Now at this point, things have started making sense. At least we can see that the n plus 1 has appeared, but we are not yet there. So in the brackets, we've already simplified that. So hoping on your paper you would have gone on the next step. So I'll just substitute that for the sake of simplicity. So we have n plus 1 over r n minus r plus 1, after adding what had remained in the brackets after factorization. So then I can move this a bit up, so that we can try to see if we can simplify it further. Okay, so I'm trying to simplify this to what is, of course, to just give you an idea, the right answer there is expected to be something like this. Right hand side is expected to be, of course, it is n plus 1 r. So applying the same concept, it's supposed to be n plus 1 factorial over n plus 1 minus the r factorial, and then r factorial. So that's our goal. Now for our left hand side, at the point where we've reached right now, what can we do? So n factorial times n plus 1. Think about it. Be smart about it. You have n plus 1 in brackets multiplied by n factorial. What can you observe? Now n factorial, or n is just less if you compare to n plus 1. So if you combine the two, they are equal to n plus 1 factorial, because I can use n plus 1 by 1, which will give me n. What I'm trying to say is 7 times 6 factorial is the same as 7 factorial. So on the top part, if you want on your paper on the next step, you can even show, you say n plus 1 in brackets multiply by n factorial. Denominator, equally, you have to be smart about it. So what we have on the denominator part, so I've got r multiplying by r minus 1 derivatory as well, and then the other part as well, derivatory, we have n minus r plus a 1 multiplied by n minus r factorial, also derivatory grouped together. That should be equal to, now the top part I've already shown you to say if you combine them, get the bigger one, so n plus 1 factorial. The denominator part, if you compare r and r minus 1, r is just less by a 1, so again if you combine them, it just be r factorial. And then this other one, this is greater by 1 as well, so if you reduce by 1, it goes to that. So you can also just get the bigger one, which is like n minus r plus 1 factorial. So at this point, on the next step, just arrange them properly, okay? But all in all, the top part is matching up, and then it's just that the r can go just, which is of course multiplication is commutative, it doesn't matter where you've placed it, and then inside there negative r and positive 1 can just be exchanged. That's still the same. So on your conclusion, you can say since the left hand side is equivalent to the right hand side, hence proven that that is basically true. So we've just used the with an understanding of our binomial coefficients and the factorial notations to basically get to that result.
Pascal's triangle. So Pascal's triangle is something that is very direct, and I believe you know, guys. So Pascal's triangle, we use, there's this triangle which we use, okay? So it just keep on going like that. So then here I've got also 4 1. So for example, the first question, which is saying to the power 4, I'm going to use this one, which is having after 1 then the next number. It's the one we look at. So the next number is 4. I'm going to look to use this coefficient. Or if you want, you can say this is the first term. We use always n choose 0. So this is more like 0. This is 1. This is 2. This is 3. And this is 4. So you use that. So these are going to be my coefficient. Meaning that when I'm trying to solve this, I'll say the first one. So 2, then I'll start with the coefficient. So the coefficient is 1. The first one is 1. Then I get 2. Then raised to the power 4. So the second one, this one, is going to be raised to the power 0. So I'll just leave it. Okay? Then plus, the next one will be, the coefficient is 4. Then I have got 2. So the power reduces by 1 to the power 3. Then 1 over x raised to the power 1. Next is going to be 6. Then 2 raised to the power 2. 1 over x raised to the power now 3. So as you can see, the powers of this guy is now increasing. So here is going to be to the power 2. Next, 4, 2 raised to the power 1. Then I'll have 1 over x raised to the power 3. Plus, the last one, this one is going to be raised to the power 0. So since it's raised to the power 0, I'm not going to be interested with it, because anything raised to the power 0 is 1. So I'll say 1 over x, the coefficient first, that is the most important thing. What is our coefficient? Our coefficient is 1. So I'll say 1 over x raised to the power 4. So if I simplify this, I'll end up having 2 to the power 4. 2 to the power 4 is 16. Then here I'll have 8 times 4, which is 32. Then 1 over x. Then here plus, this is going to give me 4 times that one is 24. Then 1 over x to the power 2. Plus, this is going to give me 8. 1 over x to the power 3. Then this is just 1 over x to the power 4. So to simplify it, I'll say, I'll write it from here. So it is 16 plus 32 over x plus 24 over x squared plus 8 over x to the power 3 plus 1 over x to the power 4. So that's my answer. Now, use the same principle, guys, to solve these remaining ones. So I'll go ahead and solve 2 more. Okay, so which ones? I think let me solve, but I'll solve E, this one and that one. I want you to go ahead and solve this and that one. So you can send the answers, or you can just, yes, you can send the answers, or you can type it in the comment section. So let's go ahead and solve part C, which is 2x plus 1 over 6 raised to the power, or plus 1 over x raised to the power that. So the coefficient which I'm going to use, it should be 1, 6. The next should be what? Because I have added 1 and 5. So in between I'm going to have this side 5 and 1. Okay. So we are saying we have 1. So we have 3, 3, 4, 6, 4, 1, 5, 6. Oh, this should be 10, 10, 5, and 1. So the other one will be 1, 6, 15, 20, 15, 6, 1. So the first, for raised to the power of 6, I will use the coefficients which are, I'll put them here. I'll use 1, 6, 15, 20, 15, 6, 1. Then I think I should go ahead and solve also part D. You can solve E, I think. Okay, I'll solve E. So E is raised to the power 7, meaning that the coefficient which I'm going to use, the next coefficient. Okay, guys, you can solve E. Let me solve F. So for F, we are dealing with 8. So the coefficient will be, that will be 7, that will be 21, that will be what? That will be 35, 21, then 7, 1. So for 80, meaning it's going to be 1, 8 in between, 21 plus that one is 28. Then this should be 56. Then these two should be 70, 56, 28, 8, 1. So allow me to put them this side, because I don't want to waste time. I don't want to come back. So I have 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay. So allow me to solve that one for to the power 6. Like I said, the coefficient I already have. I have 1. So the first coefficient is 1, 2x. The next coefficient is 6, 2x. So this has to be raised to the power 6. So the powers are now decreasing. Now I introduce x this. Now raised to the power 1. Plus the next coefficient is 15, 2x raised to the power 4. Another one, 1 over x raised to the power 2. Plus the next coefficient is 20. So 2x raised to the power 3. 1 over x raised to the power 3. Plus the next coefficient is 15. So it will be 2x raised to the power 2. Another one, 1 over x raised to the power 4. Okay, raised to the power 4. Then I'll continue from here. Plus the next coefficient is 6. I can even put from here 6. Then you have got 2x raised to the power 1. Okay, then the other one has to be raised to the power 5. 1 over x raised to the power 5 plus 1. Then I'll just have 1 over x raised to the power 6, like that. So if I'm to simplify this, guys, I'll be able to have 2 to the power 6. 2 to the power 6 is 64. So I have 64. Let me write it from this side. 64x raised to the power 6 plus that is going to be 2 to the power 5, which is 32. 32 times 6, that is 192. 192 x to the power 5. Then I divide it by, again I've got x here, plus there I'm going to have 2 to the power 4 is 16. 16 times 15, okay, is 240. So I'll have 240 x to the power 4 because of this 4, then divided by x to the power 2, plus the next one I'm going to have 2 to the power 3, 8. 8 times 8 times 20, which is 160. So I've got 160 x to the power 3 divided by x to the power 3. Next I have got 2 to the power 2, which is 4. 4 times 15, 60. So I've got 60 x to the power 2. Then I've got x to the power 4. The next one is 2 times that is going to give me 12 x divided by x to the power 5. The next one will be 1 over x to the power 6. So if I'm to simplify this, I'll be able to have 64 x to the power 6. This x there I'm going to remain with 192 x to the power 4. This there here will remain with x to the power 2. 240 x to the power 2. This there will go, I'll just remain with 160. Then there I will remain with 60 on top, then x to the power 2, because this has gone. Here I'm remaining with x to the power 2. Next I've got 12 x will go, then I'll remain with x to the power 4. Okay, so I'll remain with x to the power 4. Then down here I'll have 1 over x to the power 6. So this is my answer. Let's try the last question, which is F. I want you to go ahead and solve E. So for F, I've already gotten the coefficient from the Pascal's triangle, which we created. So we are trying to find the answer for 2xy. Okay. So I'll start from here. The first coefficient is 1. So then I have got 2x over y, but this has to raise to the power 8. Next, the coefficient is 8. So I've got 2x over y raised to the power reduces by 1 now, 7. Then the other one now is going to be negative 1 over x raised to the power 1, plus the next coefficient is 28. So 2x divided by y, then it's going to be to the power 6. Then this one now it will be to the power 2. Keep on doing plus. The next coefficient is 56. So 56, 2x, 2x divided by y raised to the power 5. Then the other one is negative 1 over x, then to be raised to the power 3, plus the other one is 70. So 70, then we have 2x over y raised to the power 4. The other one, negative 1 over x raised to the power 4, plus I also have 56 again, so it will be 2y or 2x over y raised to the power 3. Then the other one, 1 over x raised to the power 5. Then plus the other one should be, so this one I will not have enough space this side. I shift this one here. Okay. So I'm going to have the next coefficient is 28. Then I've got 2x over y now raised to the power 2, negative 1 over x raised to the power now 6. The next one, the coefficient is 8. Then you have 2x over y raised to the power 1. The other one, negative 1 over x raised to the power 7. So still I don't have enough space, so I have to shift this to the other side. Okay, like here. Then I'll have plus the next coefficient is x, just 1, sorry. So you'll have 1, then that other one is going to be 0, then negative 1 over x raised to the power 8. Now we simplify. So we are going to have 2 to the power 8. 2 to the power 8 is 256. So I'm going to have 256 x to the power 8 divided by y to the power 8, plus then it's going to be 2 raised to the power 7, then times 8, which is 1024 x to the power 7 divided by y to the power 7. Oh, so there is negative here. Let's not forget. Just a minute. There is this negative. So we need to remember that that negative is going to affect everything here. And I'll end up having negative. This part is going to be negative because of that negative. So I'll have minus, then y to the power 7 and also x. Okay, so next thing I'm going to have 28 because this is raised to the power 2, the negative is going to be cancelled out. So I'll end up having 28 times, I'll have 2 to the power 6, then times 28, which is 1792. So this one is going to be x to the power 6, then divided by, I have got y to the power 6 and x to the power 2. Okay, plus again here I'll have 56, 2 to the power 5. 2 to the power 5 is 32. 32 times 56. I'll end up having again 1000. Now this is going to be negative. It's going to be negative because of this raised to the power 3. So I'll end up having negative, then it's going to be 1792 x to the power 5 divided by y to the power 5 and x to the power 3. Okay, then plus here I'll have 2 to the power 4. So it's going to be plus because to the power 4. So it will be 2 to the power 4, which is 2 to the power 4, that is 16 times 70. So 1120 x to the power 4 divided by y to the power 4 and x to the power 4. Okay, I'll continue from here. The 56 which I have is going to be 2 to the power 3, which is 8. 8 times 56. 8 times 56 is 448. 448 x to the power 3. Okay, but because of this negative here is going to be minus. I'll have 448 x to the power 3, then divided by y to the power 3, then x to the power 5. Then plus, because x to the power 6 here is going to be positive. So 2 times 4. 2 squared is 4, so it's like you have 4 times 28, which is 112. 112 x to the power 2 divided by y squared, then x to the power 6, plus these two end up having 16. So it's going to be negative because it's x to the power 7. Negative 16x y, then x to the power 7. Okay, then again the last one is going to be plus, so we'll have 1 over x to the power 8, like that. Now I can get rid of this to see what will be my final answer. So this was bit bulk, and you need to check properly. If maybe I've made any mistake, you should be able to identify. So here I'll have just 256 x to the power 8 divided by y to the power 8 minus 1024 x to the power 7. So x and x, one x will go, so I will remain with x to the power 6 instead of 7, meaning that one has gone, divided by y to the power 7, plus I have 170.92, so 2x will go, I'll remain with x to the power 4 divided by y squared, like that. Then minus 1792. Now 3x will go, I'll remain with x squared, then here y to the power 5. Then I'll have plus 1120. All the x will go, I'll remain with that, plus I'm done with the part, so it's minus, sorry, because of this part. So I've got 448. 3x will go on top. Down here I'll remain with y to the power 3 and x to the power 2. Okay, so I'm now here. I can now get rid of this. So I have plus, what else do we have? We have 112. X will go, then down here I'll remain with y to the power 3. Okay, y to the power 3, then x, y squared. We are here. Y squared x, this x was to the power what? To the power 2. Okay, if it was to the power 2, yes, it was to the power 2, so then it's going to be reducing like we have said. So we are going to have down x to the power 4 plus it's yes, so it's minus now. So here I'll remain with 16. X will go, and it's going to be just y, then x to the power 6. Yes, then the next one is plus 1 over x to the power 8. So that's the answer, starting from there, ending here. So that is it for question 7. Now before we continue solving the questions, I want you guys to know that you can actually access the full tutorial sheet solutions for the same tutorial sheet which you are watching right now. Okay, simply just go on our website. You go on Google or Chrome, you search Transcended Institute, you'll be able to see our website. Okay, so if you go on math, you'll be able to see we have full topic videos, all the topics. We have got tutorial sheet solutions. So for example, if you want to access the full tutorial sheet solution for this tutorial sheet we are solving, you'll be able to look at you'll be able to go to Math 1120 tutorial sheet 2025. You can clearly see that there are 11 lessons already. So you click there, you'll be able to see the tutorial sheets. Okay, So you click here, you'll be able to see the tutorial sheet which are here. Yeah, there are a lot actually until tutorial sheet 7. So now we have all the tutorial sheet from the first tutorial sheet up to the last tutorial sheet. So if at all you want to access the full topic videos, tutorial sheet solutions, as well as past papers, you'll be able to see them on our site. Just check the link in the description below, register with us, you'll be able to access all of them. Okay, the past papers, we have them. As you can see, we've got the past papers for 2023 and 2024, as well as the test. Okay, then we also have some recorded classes if at all you want to access the recorded classes. For example, we are learning a bootcamp morning classes for 1 week. You'll be able to see them this side. Okay, so let's go back. Now let us go ahead and also talk about this type of questions that falls under binomial series. So the question is saying use the binomial formula to compute the following to 2 decimal places. So initially, whenever we're talking about binomial series, we are using the formula that is when we have got x plus 1, that is the opposite. When you have got 1 plus x raised to the power n, this is 1 plus nx plus n minus 1 x squared divided by 2 factorial plus n minus 1 n minus 2 x to the power 3 divided by 3 factorial. This formula is very simple. So when you write this formula, just the formula alone, they will give you a mark. Okay, so then I need to make this expression should be in a form of 1 plus something. So x can be anything. Okay, so how do I make 1.02 raised to the power 4 to be equal to in this form? So what you do is, we know that the form is always 1 plus something. So we'll say 1 plus x should be equal to what is in the brackets, which is 1.02. Now solve for x. X will be equal to 1.02 minus 1. So here 1 and 1 will go, so I'll have 0.02. Meaning that in this expression, where there is x, you put now 0.01. Meaning what we are trying to find now is this. What we are trying to find now is 1 plus where there is x, now x, the value of x is 0.02. But if you look at this, 1 plus, so now raised to the power 4. If you look at this, guys, 1 plus 0.02, if I add it, it's basically the same as 1.02. Okay, if I add this and this, it will give me 1.02. So now I just want it to be in that form. So when you find the answer here, I want you to go ahead and use a calculator. You find the exact value. So 1 plus, what is n? N is 4. X is 0.02 plus, what is n here? N is 4, then 4 minus 1, then x is 0.02. I will square it, divide that by 2 factorial. So 2 factorial is 2. 2 times 1 is 2. So now when I reach at this point, we know that this is the basic, this is the formula. Now the question is, we need to leave this in 2 decimal places, but I know that this is already in 2 decimal places. But again, if I look at this, if I multiply this, it's going to be more than 2 decimal places. So there is no need of me including this, unless if the question was leave your answer in maybe 5 decimal places, I would have included this. So there is no need of me wasting time, because I'm not going to include it, because I just want 2 decimal places. Okay, so there we go. Even here, if I look at it very carefully, I want it in 2 decimal places, I can end there. But the reason why I can't end there, because this is already in 2 decimal places. But what if the number that we're going to have here is going to be a bigger number such that we can round it off? Then that is going to be a problem. That's why I need to include x to the power 2. Okay, When we reach at this point, now we can start simplifying. So this is going to be 1 plus, if I do times here, 4 times 0.02, that should be 0.08. Okay, yeah, that is 0.08. Now let us simplify that other one. So now we are going to have 2 there, 1, 2 here, 2. So 4 minus 3, 4 minus 1 is 3, so times 3. Now we have got 6. So we have got 6 times what we are going to have here. So this is now 0.02 squared. So 0 point is the same as you have this. So 2 times 2, 4. This gives me 0, 0. That gives me 0, 0, 0. Again, this other 0 starts from there, 0, 0, 0. If we add this, we have 4, 0. We have 0, 0, 0, 0. How many decimals? So now we are counting now. It is 1, so we have got 1, 2, 3, 4. So starting from here, 1, 2, 3, 4. So it is actually, we are now doing 6 times 0.00. How many zeros? 3 zeros. 4. Like that. So now we continue with this. Remember, our answer should be in 2 decimal places. So 1 plus 0.08 plus, what is 6 times this? Let us see. We have now 0.000. How many zeros? 3, 4, then times 6. So 6 there, 12, 2 carry 1. No, it's 24. So 2, 24, it should be 4 carry 1. Then 2 times this is 0. 6 times 0 is, so it will give me 2. Then I'll have 0, 0, 0.0. So this becomes 0.0, 0, 2, 4. So if we add this, that becomes this and this will give me 1.08 plus 0.0024. So 1.0 plus 0 is 0, 0 plus 8 is this. Then I have this. So this is basically the answer. But now the question is, we need to leave the answer in 2 decimal places. So the final answer becomes 0.8, because I can't round it off from there. So that's the answer. So if you use your calculator right now, you say 1.02 raised to the power 4, you should be able to get this answer. You should be able to get that answer. Yeah. So that's the basic idea behind this. Now try to look at part B. Pause the video, try to solve it out, and then compare with the answer that I'm going to find. Okay. So use the same formula. Nothing is going to change. We need first to find it in the form of 1 plus x. So nothing is going to change. We need to find it in the form of 1 plus x raised to the power n. In this case, n is 6. So you get what is in the brackets. 1 plus x should be equal to 0.94. Then 1 plus c, you shift 1 to the other side. So this becomes x is equal to 0.9, or is 98. 98 minus 1. So that becomes negative 0.02. I think so. It should be that way, yes. Negative 0.02. So meaning now x is 1 plus minus 0.02 raised to the power 6. Using our formula, remember, nothing is going to change. So what are we going to have? We're going to have 1 plus nx plus n minus 1 x squared divided by 2 factorial plus n minus 1 n minus 2 x to the power 3 divided by 3 factorial. But for the fact that I want it to be in 2 decimal places, when I plug in the values, n is 6, x is negative 0.02 plus n6, then 6 minus 1, x is negative 0.02. Now we square it. I divide this by 2 factorial. 2 factorial is just 2. Now I'm not going to waste time to plug in here, because this one, the moment I multiplied it by 2, it will be 0.004 somewhere there, and we found this. So meaning that I've already reached on 2 decimal places, so there's no need of me plugging in the values there. I can only plug in the values there if the question says the answer should be in 4 decimal places going up. That's when I can go ahead and look at that as well. Because if you look at the answer that we found after ending on this, it was what? It was actually in 4 decimal places. So in a case where they ask you to find the answer in 4 going up, 4 decimal places going up, that's when now you can include what? You can include this. You plug in. But if they say in 1 decimal place, 2, 3, you just end there. Okay. So now here I'm going to see that I'll have 1 plus. It's not going to be plus because of this negative, it will be minus now. So 6 times this is 12, meaning this gives me 0.12. Yeah, this gives me 0.12. So what we're talking about here is this times 6. This gives me 12. 2 carry 1, then 0, 1, then this 0. That's why that's what I have there. So 2 there, 1, 2 there, 3, then 3, 6 minus this is 5, so that gives me 15. Not so. So now we have got 15 times what I have here is negative, but I'm going to square. If I square it, it's going to give me positive. That's what we need to know. Okay, it's going to give me positive. So what I have, remember, we already found 0.02 squared. That was 0.0004. That's what we found. Okay, so now this, we are multiplying this by 0.004, like that. So we have 1 minus 0.12 plus. So if I do this times 15, what answer are we going to get? So 4, that gives me 20. That gives me 20. Then that gives me 5, 0. 5 times 0, that is 0. 0 plus 2, that is 2. Then that gives me again 0, 0. That gives me 0. So here that gives me 4, 0, 0, 0, 0, like that. So this is 0, this is 6, and this is also 0, this is 0, this is 0, this is 0. So how many decimal places? 1, 2, 3, 4. So starting from here, 1, 2, 3, 4. So it is actually 0.006. As simple as that. Okay, so that's the basic idea there. I hope we are following. Yeah, I hope we are following. So this is actually 0.00. How many zeros do we have? They're supposed to be 3. That's what we found on the other question. Yeah, they're supposed to be 3, because here we have got 2 zeros times 2, so it will be 4 zeros altogether, then 4. So now we have found that one to be 0.006. So 0.006. So now let us go ahead and add this. So we have got 1 minus, I'll do it from here. We have 1 minus, let me just put 1.00, then we have got minus 0.12. So here there will be 0, 10, 9, then 1. 10 there, 8, then here 8, so it's 0.88. Now we've got 0.88 plus 0.006. So we're adding 0.88 plus 0.006. So that becomes 6, because here there's 0, 8, 8.0. So the final answer becomes 0.886 but the question is we leave it in 2 decimal places, so we'll round it off and say 0.89. That is my answer. If you use your calculator right now and look at 0.98 to the power 6, you'll be able to get this answer. Okay, so there's no debate about that one. Yeah, there is no debate about that one. So you'll be able to get this in 3 decimal places. Now I want you guys to look at using the same concept that we have just come up with. I'm going to start part C for you, and then you finish it up. You send me the answer in the comment section. So remember, it's supposed to be in 1 plus x, so that should be equal to 2.03. So x will be equal to 2.03 minus 1. So x should be equal to, so you say 2.03 minus 1, that should be, I think, 1.03, like that, not so. That's what we're going to have. So meaning that you have your expression now to be 1 plus 1.03, because where there's x you put 1.03, yes, and then raised to the power 5. So using that formula, go ahead and find the answer using 1 plus nx plus n minus 1, n minus 2, or n minus 1, we end there, then x squared divided by 2 factorial. Even if I add that other one, I don't think I'm going to use it. So in 2 decimal places, go ahead and plug in the values, send the answer in the comment section. I'll be able to check it out. Okay, so now explore different type of questions under the same topic, and then try to solve them and see if at all you can be able to find the answers.